Welcome back. I hope you enjoyed your little break, and we're going to continue now with the eye. Let's just see where we are with the human nervous system first. So like I said, we are busy now. We have done all of these concepts here, right? We are busy with the eye, and if we go even further into the eye, we have done the structure of the eye. We are going to go to accommodation now. Right, so let's continue. Firstly, we need to know some keywords. Accommodation, right, that's the ability of the lens to change shape of the lens to focus on a near or distant object, right, very important, because remember, you can't just see something here, you can see all the way there, close by. If you could only see it one place, that would be horrible. You had to go and walk there and, see what's going on. So that's why your lens can actually change shape, and that can determine where you look. That's determined by where you look. If you look far and where you look near. Right, so once again, convex. Remember, I told you convex will always be curved outside. Let me just put down the pen. Curved outside, and concave will always be curving inside. Right, so just remember those two concepts there. Right, so let's move on. Right, now what is accommodation? It's the focusing of light on the retina. And that focusing is all to do with the lens, right? Now mammals, that's now us. Focus by changing the shape of the lens, right? The lens is less convex for distant objects and more convex for near objects. And if you look at this picture here, you can see how this lens is flatter, then rounder, flatter, then rounder. And this happens all the time while you're looking around. You don't even realize that this is happening. But let's look at it more detail. So, the refractive power of lenses, that is to do with the bending of light. Right, like I said, we don't talk about bending of light, we talk about refraction of light, right? So, if you look at these three lenses, you'll see this one is very flat, and this is more round, more convex, right, convex. And if you look at this, the more convex one, it's more round, is breaking the light or bending the light a lot. Can you see? It's bending it quite a lot. So there's a lot of refraction going on here. Right, the refractive power is very strong in this lens. This one, the breaking is a bit less because this one is less round or less convex. And this flatter lens here, look how much it's refracting the light. Not a lot, eh? So it's not bending the light a lot. So the flatter the lens, the less refraction. The rounder the lens, the more refraction. That is a concept that if you understand that, accommodation will not be difficult for you. Also, when you look at a distant object, you'll see the light rays reaching your eyes don't need a lot of breaking. Right, they don't need a lot of breaking or refraction, so your lens will be flatter. Right, because it's from far and the light's already sort of in the right position. So your lens is not needing to be very round, right? But now look at what happens when you have near objects. When a near object, there's the light ray going. Can you see it's bending upwards? It's going outwards, right? So now you need a very round lens to bend this light more, or else, it's not going to have an image there. So that is, with a near object, you need a more convex lens, and with a distant object, you need a flatter lens. Let's have a look how accommodation works. It always works with your ligament, your suspensory ligament. So in this picture, you can see that it is tight. Can you see it's very tight? So it's pulling on the lens, right? So it's making the lens less convex. Here, the ligaments relax, and they are more convex. This lens is more convex because there's not a lot of tension. Small tension here, big tension here on this lens. And you need this for distant objects, and you need this for nearby objects. But let's go into more detail in the next slide. So this is what you really need to know. You can find this in Mind the Gap. Please, this is the words we are using when we are marking, and it's on the memos usually. Right, so let's start with the picture. You'll see there the ciliary muscle contracts. What happens when a muscle contracts? When a muscle contracts, it becomes bigger, right? And when it relaxes, it becomes smaller. So if you look at this muscle here, it's big. It's pulling the sclera forward, right? Because here at the bottom is also 1, right? And when that happens, this tension here is released and your suspensory ligaments are now loose. And ligaments are not muscles. You cannot say a ligament is contracting or relaxing. They are like little filaments, right? Filaments. So they cannot contract on their own. The muscle must contract, right? So children are losing marks when they say the suspensory ligaments contract. Don't ever say that. They will either loosen or tighten. Right, so when they are slacking or becoming loose, there's less tension on this lens, so the lens becomes more convex. Don't say becomes convex. The lens of the eye is always convex. It just becomes more convex. Okay, so when it becomes more convex, we saw that it will refract the light more. Right, so let's have a look at what you must know. Ciliary muscles contract, remember it becomes bigger. The sclera is pulled forward. Suspensory ligaments slacken or loosen. Don't say relax, it's not a muscle. Tension on the lens decreases, it becomes more convex, right? And then the refractive power of the lens will increase and you will have a clear image on the retina. Now let's move on to what happens when an object is further than 6 meters away. Now just the opposite will happen, right? Firstly, your ciliary muscle will relax. See how small it is now. And when it's so small, it's not pulling the sclera forward anymore, so the sclera is now moving back to the normal position. But now, look, it's actually pulling now the suspensory ligaments upwards, so they tighten. They are tightening now. And when they are tightening, there's more tension on the lens. And when there's more tension on the lens becomes flatter. But we're not allowed to say flatter, we say less convex. Right. And when it's less convex, then there's less refraction. So what must you know? Firstly, the ciliary muscles relax. The sclera goes back to normal position. Suspensory ligaments becomes taut. Tension on the lens increases, the lens becomes less convex, right? The refractive power will decrease and there's a clear image on the retina. Right, so that is basically accommodation. So let's just look at a question or two. Give the letter and name of the part that contract to change the shape of the lens. Remember that would be number A, the ciliary muscle. Controls the amount of light that enters the eye. Remember, it's not the pupil, it's the iris. It is projected, so it's a C, iris. They have both, ne? Letter and name. You can't just say iris. Is protected by the conjunctiva, slip of the word, D cornea. This part here, right there, D cornea. Right, and study diagram 1 and 2. What process is responsible for the change in the shape of the part E? Part E is the lens. So what part will now be responsible, or what process? The word is process, and the process is accommodation. Right? Which diagram 1 or 2 represents the state of the eye when a person is reading a book? When a person is reading a book, it's close by. Right, it's near. This is a flat lens. This is a round lens. So this is the one that will be used for nearby vision. So it definitely will be diagram number 2. Right.